Okay, good morning everyone. You are very welcome to UCD Library. My name is Jenny O'Neill and I'm the data manager here in the library. So I have two parts to my role, one half of which is helping people with any data management queries they have, data management plans, whether that be kind of pre-award or post-award. And I also run the Irish Social Science Data Archive, so I'll be pulling on that experience a little bit as we go through this. In front of you this morning, you have a copy of our data management checklist. This is based on guidelines put together by Science Europe. Science Europe put these guidelines together because they are hoping that we will get a cohesive data management plan template across Europe based on their template. So I've gone ahead and done that. You also have a copy of a blank data management plan as such. So the idea with that is that as we go along this morning, at the end of each section, we'll take a break. You can jot down a few notes for yourself based on your own research projects. You can ask any questions that you might have, either related generally or specifically to your projects, and then we'll move on to the next section. So the idea is that when you leave here this morning, you'll at least have the bones of a data management plan to take away with you. You don't have to show it to me, but if you want to, I will obviously be more than happy to go through anything with you or to review it separately if you want me to do that. And there's also a copy of the feedback form, which I would appreciate you filling in if you want to. So I'm going to talk a little bit this morning about why you might want to manage your research data, and specifically the FAIR data principles, which a lot of the funders are referring to now. And then we'll get right into the data management plans. So the 6 different sections within a data management plan is data description, organization, documentation and metadata, storage, backup and security. Then we'll move on to legal and ethical requirements, and then data sharing and long-term preservation. And then the final section, which is quite short, is data management responsibilities and resources. So as I said, I'm happy to take questions at any point throughout the morning, or you can wait and ask me questions at the end, and I'll be here for about half an hour after the workshop finishes as well. So if you have any questions you want to come up and ask me, we can do that. So what do I mean by research data? That's, I suppose, where the easiest place to start. So this is a legal definition. It's in one of the European directives. Morning, come on in. I quite like it because it gives you a good idea of what we're talking about. It's very broad. So just think about this in terms of your own research. So research data means documents in a digital form other than scientific publications. That bit's important. Your publications are not considered data, which are collected or produced in the course of scientific research activities and are used as evidence in the research process, or are commonly accepted in the research community as necessary to validate research findings and results. So there's kind of 2 things which are quite important here. It's the evidence. So your data are the evidence which underpins your publications and that are necessary to validate your results. So if you kind of think from that as a basis, what would someone else need in order to validate my results within my publications? That's a really good place to start. Research data can be pretty much anything, and this will be very much discipline dependent. So you can have interviews, anthropological field notes, digital audio or video recordings, models, maps and geospatial data. Ephemera, archival material is also considered data depending on the discipline, numerical data, audio and video recordings, database content, any software that you might be designing or using, lab protocols or methodological descriptions. These are all considered research data. So if you start to kind of think from, well, what would someone need to verify the results of my publications, that will hopefully give you a better idea of what research data means within the context of your research. When we talk about data management, it's at all kind of steps of the research process. So as you'll see this morning, as you start to create data, you need to be thinking about certain things. You need to document what you're doing as you go along. While you're using the data, this is the one part I don't talk about. You are the experts in your own science, and I don't have a disciplinary knowledge of every single discipline on campus. So I won't be talking so much about how you actually use the data. That's up to you guys. But I will talk a little bit about how you store the data while you're working, and also long term, how you might share those data at the end of the research and then preserve them for the long term. So you can see that we have kind of day-to-day management, and then kind of more long-term management as well, which covers the entire research life cycle. In terms of RDM support, so I'm based in the library, obviously. But I collaborate very closely with colleagues across campus. So if I can't answer your question, usually I can tell you who to go to and who will be able to answer your question. So we work closely with UCD Research, with Research IT, with the data protection group as well. So they have a specific website. I've been quite careful not to learn too much about data protection so people can't ask me questions. But I will definitely point you in the right direction if you have any specific questions around those. The Office of Research Ethics as well. And then if you have any intellectual property within your data, or you are working with commercial companies and you need a little bit of advice around that, UCD Nova can help you with those. So as I said, if I can't answer your question, hopefully I can point you in the right direction. Why would you want to manage your research data? Surely this is just like an administrative task that I'm annoying you by asking you to do. I quite like this quote. I hope it makes sense to people. Your research data is a valuable resource that will have taken a great deal of time and money to create. Therefore, it's worth looking after it properly. So when you're thinking about your data management plan, there's a couple of different levels you might want to think about. So the first is just basic quality assurance within the project. So this will help to increase your research efficiency because you'll have documented everything that you need for yourself. Everything will be easy to find. And will facilitate data security and minimize the risk of data loss because you will have a backup policy in place. So you might want to have a backup strategy within the project, data organization and collection and guidelines, versioning guidelines for yourself. If you imagine that you're at the start of a 4-year project or a 5-year project, are you going to remember by year 5 what you did in year 1? And if you're me, definitely not. That seems like 4 years ago is a long time. File formats still fulfill the need of the primary research group, so you don't need to worry too much about what file formats you're using as long as they're useful to you. Minimal documentation, so you might want to label all your variable labels and code labels so that you know what SAM 1, SAM 2 and SAM 3 refer to 4 years later. And then informed consent to use the data within the project if you're working with any human participants. The next level up then, so that's kind of basic quality assurance, you just want to make sure that you are doing things in the right way, is reproducibility of your research findings. So if this is something that's particularly interesting to you or which is required by your funder, you might want to think about a backup strategy for 10 years post the project. File formats which will be accessible for 10 years or so, so you might want to think a little bit further than just what you need right now. Metadata to describe the entire research process, so make sure that you have everything documented very well, so that if someone says, oh, I have a question about your research, your results, and I'd like to see the data underlying them, that you can provide them with everything that they need in order to validate your results. And then informed consent for the data storage and making it accessible to others under those kinds of conditions if you're working with human participants. The third level, which is where the funders are trying to point you at the moment, is the reuse of data by other researchers. So you want to ensure wider dissemination and increased impact of your research by making the data available. And you can enable research continuity through secondary data use. So that also means that you will benefit from the access to data that other people have generated as well. So within your data management plan, then you want to think about submitting your data to an archive or long-term data repository so that other people can access them. You might want to think about organizing your data a little bit more and using standardized scales or licensed scales, which means that then your data are more interoperable with other people. And again, that will depend on the discipline you're within. File formats that facilitate data reuse into the future. So if you think your data are really, really important and you want to make sure that they're going to still be accessible in 50 years' time, you might want to think about what data formats are going to be most suitable for your data in that case. And then informed consent for archiving or reuse as well. And detailed documentation, documenting everything that you did so that someone else can come and take the data and reuse them without having any questions about what has happened during the research process. So within Ireland, the Horizon 2020 have already mandated the completion of a data management plan, and they had a data pilot to get people to produce their data and to make those available through a data repository. The Irish funders now are also getting on board with this. So in the UK, they've been doing this for about 10 years or so. So most of their policies are quite well established. In Ireland, the HRB are the first people to kind of put this into a formal policy. So they are going to have a new policy, data management policy from January of next year, which will mandate a data management plan post-award. So at the moment, they're going through a pilot. They're in the pilot phase, and I'm involved with that along with one of my colleagues from Research IT. They mandated that a data management had to be considered at the application stage. They also wanted costs associated with data management to be considered at the application stage. And then for those people who were awarded, they wanted a full data management plan at 3 months post-award. So this is kind of a testing of how it will work long term, but their policy is coming into place in January. So this is going to be just part of the research process with them. They are also working really closely with IRC and SFI because they want to get kind of a national approach to this, a national policy. The benefits of that to you guys is that we will hopefully have one national template, which will be based on those Science Europe guidelines that I mentioned earlier, so that when it comes to your next research project, you won't be starting completely from scratch with your data management plan. You'll hopefully be able to take elements of it with you. So I think it's only a matter of time. I know the IRC are very much asking at their application stage now for people to consider data management and asking for about 300 words. I've had a good few people come to me about that. And then SFI, I've actually had 3 different people come to me in the last month who have a midterm SFI review, and the SFI are asking about data provenance, which is essentially data management. So where have the data come from? How have you ensured that they're of good quality as you're going along? So the funders are beginning to ask them more and more, and I think it's only a matter of time before this just becomes part of your research process. Has anyone heard of the FAIR data principles? Okay, 1, that's great. Okay, a few, that's great, okay, a few. So these are principles, they were brought into effect in 2016, and the idea behind them is to enhance the value of all digital resources. So FAIR stands for findable, accessible, interoperable and reusable, and nearly all of the funders are using this acronym now within their documentation. If you're interested in making your data FAIR or learning more, this is the best resource I can point you to. It used to be called biosharing.org, and now they've changed it to fairsharing.org, and they've expanded the range of disciplines that they support. But they have a huge amount of different data and metadata standards. So you can go there, you can type in the type of research that you're doing, and they will help you to find the standards that will help make your data more fair. So findable means it should be possible for other people to find your data. The easiest way to do that is to put it in a repository or archive. I haven't seen it so much recently, but when I started this job about 4 years ago, a lot of people were saying, we're going to put our data on our blog. We're going to put our data on the project website, and therefore it will be accessible to people. But most websites have a lifespan of about 2 years. And if you think of the recent referendum, those websites were gone within a couple of months of the referendum having finished. So websites aren't something which is particularly long-term lasting. Rich metadata should be available online and should be assigned a persistent identifier. And I'm going to go through each of these terms as we go through the rest of the morning. Accessible means it should be possible for them to gain access to the data. So not just that you can find them, but that you can also access them under clear conditions or restrictions. So FAIR doesn't mean that your data have to be completely open. You can put access restrictions in front of them. So for example, with ISDA, the Irish Social Science Data Archive, the data are only available for research or teaching purposes, and we review every single application on an individual basis that comes into us to say, yes, you can have access, or no, you can't. So those data are still being made accessible, even though they're not openly available to just anyone. And even if you can't make the data available, there are a lot of good reasons why you can't. You should ideally still make the metadata available so that someone can find the information that describes the entire research project, even if you can't make those individual data available. Interoperable refers to the conforming to recognized formats and standards so that they can be combined with other data and exchanged with other researchers. So you want to think about the file formats that you're using and any other standards that are commonplace within your discipline so that your data are interoperable with other people's data and vice versa. And then reusable means lots and lots of documentation to support interpretation and reuse, so that another researcher basically has everything that they might need in order to reuse your data. And it's also important to apply a license to your data, so it's very clear the conditions under which those data are allowed to be used. If you're uploading to a repository or archive, they will usually either have a standard license under which they allow access, or they will allow you to choose from a drop down. So it should be relatively straightforward. You don't need to know kind of the legal ins and outs necessarily, but it's just worth thinking about. So steps towards making your data findable, accessible, interoperable, and reusable. So at the very kind of base level, you want to make your data available in a repository or archive. You want to make sure that a persistent identifier is assigned to those data so that they can be found again. You're probably familiar with DOIs that you might see at the end of a citation for a publication. That's a digital object identifier, which is a type of persistent identifier. So most archives and repositories will assign a DOI to your data in the same way that they would assign it to your publication, and it just means that you can track it a little bit easier. Rich metadata, and again, I'm going to go into quite a bit of detail as to what I mean by metadata, and a clear license. So if you tick those three boxes, you are some way to making your data fair in the eyes of your funder. And if you see them asking about making your data fair within your funding application, this is really what they mean. Are you going to make your data accessible online? So while I talk an awful lot about sharing research data at the end of the process, there are lots of good reasons for managing your data, even if you don't intend on sharing them, and hopefully that will become clear as we go through the morning. Okay, so a data management plan, which I've been talking about for 20 minutes now, is a formal document describing how research data will be managed and documented throughout a research process, and the terms regarding the subsequent deposit of the data within a data repository for long-term management and preservation. It is designed to be a working document. It is designed to evolve as the project evolves. It is also designed to be helpful to you. So you can imagine if you're working in a team of 5 or 10 people and you have some staff turnover, you have someone new join the team, or there's some kind of recruitment going on, you have a document that you can point them to which shows exactly how they're supposed to be doing all of these different things and documenting what you have done to date. So where all your files are located, how they are being backed up, how they're being named, what metadata they should be capturing as they go along. It also means if you have a few different people working on the same kind of data, that they have kind of guidelines which they need to follow to make sure that everyone is on the same page with these things. So people will often ask me, when should it be updated? And I think the easiest answer is if you have like a midterm review with your funder or something like that, that's a good time to look back at the data management plan and see if it needs to be updated. Or if there's some big change to the research project, or suddenly you realise, do you know what, we hadn't factored in the fact that we were going to have video data with this project, for example, you'd go back and look at your data management plan again and see what changes might need to be made. So really it is meant to be something which is useful to you, and I hope it will be in the long term. So most data management templates have these various different sections, and I'm going to go through each one of them individually, and then you can ask questions at the end of each section, and you can also fill in your blank template there in front of you. So just think about your own research project or one that you have coming up that you're going to be applying for funding for, and jot down a few notes for yourself. The DMP online is a really good resource for creating data management plans. So a lot of different institutions have their data management plan templates within this online resource. You can sign in using your UCD credentials, so you don't need to really sign up for an account. You can just go in and use your UCD Connect email and password, and that will get you in. And then you can select from the drop down. So if you are HRB funded, for example, you can select their template from the drop down, and they have additional advice on that. UCD don't as yet have a template in there, but we're working on it, so hopefully we will at some point in the future, and that means that any of our tailored advice will also be available as you're going along. You can share that with collaborators or with me if you want me to review it. It kind of shows you how many questions you've answered, so how far along you are, and then you can export it at the end in a PDF or a Word document or various different formats like that. So it's a really useful resource to have. If you're looking for sample DMPs, I don't use a huge amount of examples within these workshops because the disciplines are so different and the size of the research project is going to be so different. But there are at these 3 different links various data management plans available that you can look at from other people that have been published. These are published without a review having been done, so just a little little caution that it's not that these are the best of the best. It's just that these are the ones that have been published. So just take it, review it and see whether you think it's suitable for your purposes or not, because there's no quality assurance done on them. Okay, so let's start into the first section of your data management plan then. So think about what data will be collected or produced and how new data will be collected and will existing data be reused. So the reason that the funders are interested in existing data is that they want to fund the data collection once and not multiple times. So if the data already exists, they will be asking you, well, why aren't you using that existing data? Why do you want us to pay a couple of €100,000 to recreate the same data that already exists? So within data types, you want to give details on the kind of data that you're creating. So whether it's an interview or a questionnaire or some kind of experimental measure, and what data format will be used. So you might have one data format for your analysis, and you might have a second data format for long-term access. And when you're considering what data formats you want to use, so how do you plan to analyze your data? You want to obviously have data formats that are useful to you. Which software are you familiar with, have been used by your colleagues, by your supervisor potentially? Any discipline-specific norms or technical standards, these are the kind of things that you want to take into account. But then also what formats are useful for long-term preservation of data. So if you tend to work in Excel, for example, Excel is a proprietary format. It's owned by Microsoft. And while Microsoft are probably unlikely to go away in the future, I'm sure we all have Excel files, old Excel files that we can no longer access. Whereas if you save that as a CSV, which is a comma separated value file, which can be opened by Excel, but it can also be opened by multiple other different pieces of software. You don't need any specific software to open a CSV file. And it will preserve all the data for you. So you might want to work with Excel, but then share or preserve in a CSV file. Similarly, for textual documents, you might be working within Word, you might be working within software like NVivo if you're doing some kind of analysis. So you'll have NVivo files, but at the end of your research, you might want to convert those either to just plain text files or to a PDF, because those are going to be easier to maintain into the long term. And the possibility of embedding metadata within the files as well is something you might want to think about. There are many advantages to reusing existing data, and as I said, the funders are particularly interested in this because they just want to fund these things once. They don't want to waste money funding the same project over and over again. So it might be impossible to create the data within the scope of your research project. So if you're a PhD student, you may not have the time to go out and interview hundreds of people from across a huge geographic area. You might find that that has already been done within your area. I don't know if any of you are familiar with the Growing Up in Ireland study, or TILDA, which is the study of aging within Ireland. These are longitudinal studies, so they go back to the same people year after year after year. That's something that you're not going to be able to do necessarily within the scope of your research project. They make all of their anonymized data available so that people can reuse them. So stuff like that is really, really useful. It can be cost effective and time saving, so someone else has already done it, why not use it? And any ethical issues about data collection have already been dealt with. So they have already dealt with the consent issues, the GDPR issues, the archiving issues, things like that. And you can spend the bulk of your time just analysing the data. You can just get straight into it. There is quite a breadth of data available even in the Irish context, with some caveats, obviously. So there are disadvantages as well to using someone else's data. So you weren't involved in the original research project, so you didn't have influence over how things were collected or what quality assurance procedures were put in place. So you didn't have that kind of hands-on control. some information may not have been collected, so we will often see questions about, people are very interested in rates of breastfeeding and things like that within Growing Up in Ireland. But if someone is specifically interested in this kind of information, they might kind of wonder why weren't specific follow-up questions asked. So that might be kind of frustrating to you that certain questions may not have been asked. You might be looking at a slightly different time period, so the data might not be current or completely up to date, or it might be a slightly different geographic location that you were interested in looking for. Variables may have been defined or categorized differently to how you would have done it if you were involved in the research project. And anonymization can be quite extensive. So if you need to know the discrete age of participants, using anonymized data is probably not going to be sufficient for you, because generally when people anonymize, they remove any direct identifiers. Things like ages are generally banded, so you might have people between 1 and 9, 10 and 19, 20 and 29, for example. Geographic location will usually be top coded in some way, using various different standards. So you might only have information on people from Leinster or people from Ireland. You might not be able to get those discrete locations. And things like within Growing Up in Ireland with family size. So most families these days tend to be smaller. So any families, I think it's any families that are greater than 7 children will be top coded, and we'll just say 7+. Because obviously if you have more children than that, you are more likely to be identifiable within the data. So anonymization can be quite extensive. Okay, so let's have a look at our piece of paper. Within data description, have a think about what data you will be collecting or producing, and how will new data be collected or produced, and how will existing data be reused, or are there any repositories within your discipline that you're aware of that may have something that would be useful to you. I've given you a little table at the top because I think it can be quite useful to think about these from that point of view. So the type of data, what format you're going to use, and then also the volume of data as well. So how much data do you think you're going to be generating? And that just means, do you need terabytes worth of storage, or do you need gigabytes worth of storage? Obviously that will then affect your storage plan for the research project. So does anyone have any questions so far on any of this?
Are the funding agencies willing to fund data management?
Yes. Yeah. So a lot of these things will and I have a couple of slides at the end about the funding of it. A lot of these processes are possibly things that you're already doing, but maybe not considering data management. Like you will need to have some kind of storage facility, some kind of backup facility. Where the extra time comes in is to prepare the data for archiving. There can be a lot of time involved in that, but they are willing to fund that. If you need to access data, Tilda, for example, I think costs something like €10,000 to access the full researcher microdata file for that, and they will fund that. So they'll pay for that because obviously that's going to be a lot cheaper for them than you going and trying to recreate that type of data again. So if there are data access costs, if you need to pay for a specific person, so if you've got a really big research project and you think, actually, do you know what, we need someone dedicated to this to look after it, they will fund that. If you have any additional storage needs, they will fund that. The question that's still outstanding is, so a lot of people are saying about 5% of your budget should be data management. We're saying that should be 100 plus 5, and the funders are kind of pushing back and saying it's 95 plus 5. So that's where the tension is in terms of the costs associated with this. So whether this is an additional cost on top of your funding grant, or whether it's expected to come from within your grant. I was at a workshop recently where someone from Wellcome was saying that if there are no data management costs within the project, that would be raising red flags to them, because it means that people aren't thinking about things like storage and long-term preservation. So let's move on then to organisation, documentation and metadata. So these are the questions you want to think about as I'm talking. What metadata and documentation will accompany your data, and what data quality control measures will be used within the research? I'm not going to talk so much about the quality control because, again, that is incredibly discipline specific. These are things that you're probably already doing. I had a conversation with a researcher the other day, so I really don't know what to put in here. But we do like we would analyze the statistics, and if there are any outliers, we would go back and rerun the processes again. I was like, well, that's data quality control. The researchers just want to make sure that you're producing really good quality results that you can stand behind. So in terms of naming your files, you might want to think about, particularly if you're working on quite a big project, having a consistent file naming structure across the project for all of your files. This means it should be really easy for you to identify what's in the file immediately just by looking at the file name. Meaningful but brief. And again, how you do this is completely up to you. The key is consistency. It is better to avoid lowercase letters or spaces. Some software programs still have trouble with those, so it's best to use lowercase letters and to use a dash or an underscore rather than spaces. And if you're going to use a date, this is the recommended date format. It's year, month, day. And the reason for that is that this is an international standard. Dates are notoriously difficult for computers to deal with because we have so many different ways of expressing them, but they're also an incredibly useful piece of data. And it also means then if you want to sort your files chronologically, you can do that quite easily. Or if you want to use that for version control, that you can see, well, this was done on the 6th of December, the other one was done on the 8th of December, therefore it's the newer version of the file. When you are organizing your data and coming up with the folder structure at the beginning of the project, again, consistency is the key really to all of this. It should be meaningful to you and to your colleagues and allow you to easily find your files. So again, if you are creating files in year 1 of a 4-year project, will you still be able to find them in year 4? If you've thought about this from the beginning, you should be able to. And then when it comes to version control, some pieces of software will have version control built into them, which is quite nice. If so, make use of those facilities. If not, just something as simple as version 1, version 2 in the file name will help you with this. You can include things like draft or final, but we're really careful with those because I have seen so many times like final revised or final 2 or definitely the final. This one is definitely the final. There is one of the schools, and I can't remember which one it is, I genuinely can't remember, who has a file on their website, because I happen to be looking at it someday, which is final version 4, definitely the final, in the file name, which they published on the website, and I just had a little giggle at that. So just be kind of careful with those kind of things. I'm sure we've all done it. But you can include things like this is a cropped image, so that's what makes this different image different, or these data have been normalized, so that's why these data are different. It's a different version from the previous. In terms of documentation, good quality documentation will allow other people to understand and interpret your data. It also means if you're doing a PhD, when it comes to your Viva, that you have all of your steps documented as you go along. Or it means if someone has a query around the results that are in your publications, that you're able to prove the steps that you have done. So you could have code books or a data dictionary if you're working with statistical data, information sheets, consent forms, your ethical approval, blank consent forms obviously. If you're creating a database, you might want to include the database schema so that someone else can understand how the data are organized within the database. Any methodology per reports or provenance information about where you have gotten your data from. So any of this can be considered documentation. And again, if you think of what you might need in order to be able to interpret your data or someone else might need, then that's kind of a good starting point. Has anyone heard of the term metadata before, apart from me saying it 100 times already today? Okay, a few people, that's good. So within the library, we are very familiar with metadata. Metadata tells us a story about the data. It is information or data about data. You can have structured metadata standards, for example, Dublin Core is quite commonly used, or the Data Documentation Initiative. And if you are interested in finding one for your discipline to see if any exist, either talking to your supervisor or colleagues who might be familiar with them is a good place to start, or have a look at the Research Data Alliance Metadata Standards Directory. So if you think of going onto the library catalogue, You search for a couple of keywords which are relevant to your research, and you find a book which is relevant, and you click through to the record for the book. You'll see information about who wrote it, when it was written, who published it, what the title of the book is, how many pages are in it. You might see some subject keywords, for example. From the library's perspective, we will also have taken note of how tall the book is, which is important for us when we're shelving, to know how tall or how far apart our shelves need to be. So some information is just for us. Most of the information is for you guys. This is all metadata. So the author, the title, the year, the publisher, that's all information about the book. It tells you what's in the book. It doesn't give you the actual book itself. So that's metadata. Dublin Core, as I said, is quite a commonly used one. So this might be a good starting point if you're thinking about this in terms of your own research. So this was developed to be useful for kind of all digital objects. It contains 15 different elements. All of these are repeatable. There are no set ways in which you have to fill in any of these elements, but there are recommendations. So like I've already talked about date a little bit and about how you might record that using one of the international standard for date. So the title, what's the title of the data set? Who created it? What date was it created? A description of it, so just a textual description. What rights are assigned to it? So who owns the data and are they licensed for reuse? What type of data is it? What language is it in? Will be incredibly important when we're working in multinational projects or cross-national projects. Who were the additional contributors to it? So who else needs to get credit for these data? Is it related to any other data either within the project or outside of the project? Where did it come from? What's the source of the data? The coverage can either refer to the geographical coverage or the time coverage. So you may be looking at data that were generated 10 years ago, but you're only publishing them now for whatever reason. So that coverage is going to tell you the time span during which the data were collected, which might be relevant. Subject keyword, most of you are probably familiar with already putting a few of these together for your publications and your articles. An identifier, this will generally be assigned by the archival repository that you upload to. What format is it in? And again, you may have multiple different formats depending on what you want to do with it. And who is the publisher? So again, either UCD or the archive will generally be the publisher. Within the library sphere, we would obviously have Wiley or Springer or whomever would be the publisher then, if you're talking about a publication. So here is a book about metadata. So the title is Metadata for Information Management and Retrieval. The creator was David Hines. The date of publication was 2017. This is a little textual description which tells you what the book is about, and it's a type of book. The type of data is book. So that's just a really kind of basic information about this book. Here's a photograph of my 1-year-old daughter. The title should be something different. I am the creator. This is the date that the photograph was taken, and the description is baby F sweeping the back garden with a sweeping brush 3 times her size. She has gone from being obsessed with sweeping things to brushing her teeth, which is great, except she took a toothbrush and used up toothbrush out of the bin the other day, and I found her using it, which was great. And it's sort of a type photograph. So again, this is a piece of data. This metadata describes what's in the photograph. And then if you're doing some kind of interview, you will most likely have audio recordings and transcriptions, for example. So the title of this piece of data is interview 1. I can be the creator. This is the date that the interview took place on. It's interview participant number 1, and it's of type audio recording. So it could also be type document or type textual type document if it's the transcription of the audio interview. So again, this is just metadata describing what's in this file. So let's go back to our checklist again and have a look at the next section on organization, documentation, and metadata. So can you think of what documentation and metadata you would need to produce or collect as you're going along to accompany the data, and are there any quality control measures? So I'll give you a couple of minutes to fill that in, and then you can ask any questions on this section as well. Yeah?
Actually store the metadata in a file?
So it can either be an Excel file, When it comes to uploading it to a repository or archive, they will generally have some kind of template that they want you to fill in. Again, that might be an Excel file, or it might be a Word document that they want you to fill in, so that they're creating the structured metadata, like the Dublin core. Some of it can be embedded within the files itself, so it kind of depends. But I would think with interviews or something like that, having an Excel spreadsheet that has the 15 different Dublin core elements and filling them in as you go along is going to be quite useful to you. So it means when it does come to the very end, either of your PhD or when you're coming to deposit with an archive or repository, you have all that information at the tip of your fingers. It's going to be a lot easier to do that than getting a postdoc and giving them a week to try and collect all this information together 2 years later. So if you know from the very beginning of your research project what archive or repository you would like to publish your data in, they may have a data template or that metadata template that they want you to use. So we have a draft of a data management policy within UCD, but this hasn't been finalised yet. The reason is that we don't have the resources to fully support it yet. So that's being looked at the moment. And that's one of the issues that we're talking about. What we would normally recommend, though, is you find a subject or a discipline-specific repository as your first port of call. So if one exists within your discipline, your data are going to be more findable because you'll have other researchers within that discipline looking in the same place. They will also be able to give you good advice on what metadata to use, what file standards to use, other kinds of things that will help make your data more fair. But if one doesn't exist, then there are a couple of different multidisciplinary repositories that can be used, and this is something that UCD is looking at. There's a resource called read3data.org, and that's normally where I would point people to. So this is a repository of repositories. But all of the repositories within there have to be associated with an academic institution and stuff like that, so that you can kind of have some kind of assurances. There's certification for repositories now. A common one is called the Core Trust Seal. So ISDA, the repository that I run, has this Core Trust Seal, which goes through various different things like that we have to say about our processes that we have in place. So if you see the Core Trust Seal on a repository, that's kind of an indication that they have at least gone through this certification process. So let's move on to the next section then. This is storage, backup and security. So again, the things that you need to be thinking about are how will data be stored and backed up during your research, and how will data security and protection of sensitive data be taken care of during the research. So this is not my particular area of expertise. We do have a research IT team on campus within IT services. We also have security experts over there as well. So I'm mostly drawing on what they have told me and the information they have given me. So if you have a query for me about where you're going to store your terabytes of data, I'll be passing you over to them. So that's just a little caveat. So within UCD, you have access to a number of different file storage options. Google Drive is the obvious one, which I'm sure a lot of you are using. Microsoft OneDrive also, and if you are a staff member here, you will have access to Novell, which will give you a certain amount of personal storage. It's quite a small amount, and then you can also get team drives as well within that. You can access that off campus, but it's a little bit more fiddly, and people who are not UCD staff members will not have access to it, so it is a little bit more secure. So just to be aware of those, and you can go and read up on all of the different benefits that are available within each of those. So those are the storage options that we have access to. When it comes to where you should put your data, you need to kind of think about how sensitive your data are. So would you consider them to be in the red category? So protection of the data is required by law. So under GDPR, for example. So if you've got personal data, it's almost certainly going to be in this red category. In which case you should be either storing them on Novell or an encrypted storage device. But if you have green data, which really there's no sensitivity in it at all, then Google Drive is going to be sufficient for that. If you've got amber data, so if you think there's some sensitivity in it, you need to protect it a little bit more, then it's worth thinking about maybe encrypting it before you put it into somewhere like Google Drive. So Google Drive is not suitable for your sensitive data. If you're collecting patient data, for example, it's not suitable. And the reason for that is that we are the weakest link when it comes to this. So it's not that Google isn't trustworthy or that it's not properly backed up or it's going to be lost. All of that is very secure, so it's secure from that point of view. But a number of staff Gmail accounts or UCD Connect accounts get hacked every week. So passwords that have been used on multiple different types of accounts or through phishing, or the people who are trying to get into our UCD accounts are getting more and more sophisticated. So it's worth just thinking about whether or not your data are suitable for Google Drive, or whether you need to encrypt them first. And again, this is advice coming from Research IT and IT security. So how should you go about protecting your data? So make sure that all of your devices are fully up to date. Most of those really annoying updates that you have to apply can include security patches, so that you know that all of the security within the pieces of software that you're using are up to date. Sophos is available to all staff and students, and that's for your personal devices as well as your work devices. So please go and install that. It's available to anyone. Control access to your machine. So when I'm walking around the library, I regularly see students who've just walked away from their laptop and left it open with the screen there. If you've got sensitive research data on that machine, it means that anyone could just walk up and sit down and start to have a dig around. Now, that doesn't tend to happen, but it's just you do need to be careful about who you're giving access to your machine. Use secure connections. So within UCD, we have two different Wi-Fi connections. One is the UCD one. This is completely open. Anyone who walks onto campus can get access to it, and they don't have to put in a username or password or anything. This makes it incredibly user-friendly, but also incredibly insecure. So if your laptop, and I can see a few of you have laptops there, are connected to that network, then there is potentially a security risk within that. It's much better to be using EduRoam when you're on campus, because at least there's some authentication with that. You have to at least log in. So there's kind of another layer of security there. And then protect your sensitive data. So consider encryption. Consider keeping it not on a laptop that you might be keeping it in a locked room. Like we hear all the time about people leaving laptops on trains. I know I did it with a mobile phone once, left it on a train and never saw it again, or leaving laptops in the back of taxis with PhD data on it. So just be a little bit more careful when you do have sensitive research data within it. If you're downloading nefarious pieces of software, I'm not saying don't do it, but I'm saying don't do it with the same computer that you have all of your thesis data on, and the only copy of those data, because you just don't know what those pieces of software might try to do to your devices. Within UCD, we do have a data protection or a password protection policy. So it's worth having a quick look at that and making sure that you're complying with it, and that all of the people within your research group are complying with it. So it has to be unique to UCD. A couple of years ago, LinkedIn was hacked, and a load of UCD passwords went out with that, because people were using the same password for their UCD Connect account as they were for LinkedIn or for Twitter or for Facebook or whatever. So it must be unique to UCD Connect. It has to be at least 10 characters long, and then containing 2 of these 3 particular features. So again, just have a look at that. Make sure you're aware of it. Make sure the people in your research group are aware of it and are keeping their passwords unique. And that will help to secure something like Google Drive as well. When it comes to a backup strategy, ideally you want to have 3 total copies of your data on 2 different mediums or 2 different storage devices, and 1 copy off-site if appropriate. So that means if UCD goes up in smoke in the morning, hopefully it won't, you will still have a copy of your data. So some of the research groups on campus who have sensitive data will have 1 server in Daedalus and 1 server in the IT services center, which is, they're on opposite ends of the campus. So they're taking a bet that if, both data centers are unlikely to go up in smoke at the same time. So if you've got sensitive data, there are ways around having multiple copies on campus, but they are still geographically separate. So you don't want to have your laptop, your USB key, and your a hard drive, but all of them in the same office, that gets robbed or there's a flood or something happens to it. So think about having 3 copies, 2 different types of storage media, so that if one of them goes corrupt, you can still get access, and 1 copy offsite if that's appropriate. And then obviously Google Drive, if that's appropriate for your data, is considered an offsite copy because it's in the cloud and you can access it from other geographic locations. But please don't keep that as your only copy, because as I said, staff accounts get hacked all the time, so we just have to be a little bit careful with that. Encryption is a secure method of scrambling messages so that the format is unreadable by unauthorized users. So you can either encrypt your entire computer or you can encrypt individual files. But if you encrypt your entire computer, if you feel that this information on your computer is so sensitive you need to encrypt the entire thing, if you lose the password, it is unretrievable. That is the point of encryption. Other people can't break it. If you are emailing encrypted files, please do not email the password either with the file or in a separate email. So if someone hacks into the email, they will have both the file and the password, so you might not as well have bothered. So if you are sending encrypted files, please either ring the person up or send them a text with the password. It's much more secure to do it that way. And then if you are sending either large files, either across campus or outside of UCD, or you just want a little bit of extra security when you're sending those files, you can use HANet File Sender. It also now has native encryption in the last couple of years. So if the file is under 2 gigabytes, I think you can encrypt it within File Sender. So you can use it to really securely send things. And then those data are only available for, I think it's a month. So once you send the email to someone with the link to File Sender, that only stays accessible for a month. So you kind of know, well, I'm not having multiple different files in multiple different places that I have to keep track of, because I know that's going to be deleted after a month. So just again, either text the person or ring them up with the password though, rather than emailing the password to them, if you are encrypting using it. So that's quite a nice service. If someone outside of UCD wants to send you a large bulk of data or something that's quite sensitive, you can go on to File Sender, put in your UCD Connect details, and you can send them a voucher, which essentially gives them kind of one-off access to it so that they can send stuff to you as well. Okay, so thinking about security, storage, and backup, have a look again at your blank template and just jot down a few notes for yourself on how you will store and back up your data and how you will protect any sensitive data within your research project. And if anyone has any questions, I'll do my best to answer them. So now we're going to look at any legal or ethical requirements or restrictions that you might need to consider within your data management plan. So if personal data are processed, how will compliance with legislations on personal data and on security be ensured? And how will other legal issues, such as intellectual property rights and ownership, be managed? So these are the things you need to be thinking about as I'm talking in relation to your own research project. So most of you are probably at least somewhat familiar with the fact that we have data protection legislation. In 2018, this became much, much stricter. So the General Data Protection Regulation came into effect. This is kind of a cross-Europe piece of legislation. And it just means that we have to be a little bit more careful and people are a little bit more aware of what you can and can't do with the data. It applies to any research that uses human data or personal data, including scientific research and studies in the arts or humanities. And we also have introduced within Ireland, so there were various different, I suppose, annexes to the legislation that the different countries could choose to implement or not. Ireland has implemented the health regulations. So if you are working with health data, make sure that you are familiar with those. And the HRB has a lot of really good advice on their webpage about the health regulations in particular. Within UCD, we also have a website. So it's ucd.ie/GDPR. So hopefully your questions will either be answered there or you can get access to the data protection officer on campus if you have any specific queries. So again, I have done my best. I know a little bit about it. I've done my best not to learn too much so people can't ask me questions. Also, I'm not a legal expert. So if you're conducting any study involving human participants and you want to make the data available at the end of the study, you need to ask for consent for that. Once you are archiving, the legal basis for archiving anonymized, so once the data are anonymized, they are no longer subject to data protection legislation. And the legal basis for archiving of certain personal information under restricted conditions would be that it's to the benefit of the nation. So there is a clause within there, and I don't remember it off the top of my head, that we would archive under that legal basis. But if you are, it's always good to get informed consent from your participants if you want to make the data available at the end of the research project, just so that they know what they're signing up to. So in terms of anonymization, as I said, anonymized data are no longer considered personal data, but anonymization is a lot more than just taking out the direct identifiers. So direct identifiers might be the name, address, postcode. Photographs are also considered direct identifiers because people are immediately identifiable from them. But you also need to think about the indirect identifiers. So when linked together, that could identify someone, such as workplace, occupation, salary, or age. So I was recently asked to take part in a research project where I was told that they were not collecting any personal information and the data would all be anonymized. The first question was, what was my job title? And the second question was, what institution do I work for? I become immediately recognizable and identifiable, even though the person never asked for my name or any what we would consider direct identifiers. Another example that I like to use is a number of years ago I was asked, well, in relation to a sports data set, if we have a 28-year-old Lithuanian basketball player living in Louth, is that person identifiable? And you would have to say that given how small Ireland is, that most likely yes. So again, Lithuanians, we wouldn't have a huge population of Lithuanians here. Louth is quite a small county and basketball wouldn't be one of the most popular sports. So immediately you would say, yeah, it wouldn't be too difficult to track that person down. So as well as removing all the direct identifiers, you need to think about how combinations of indirect identifiers could be used to identify someone. And then you can balance anonymization with access control. So sometimes when you anonymize data, you actually make them kind of useless. So I was talking to a researcher who had data on cystic fibrosis patients, and she explained to me that if you removed the year of birth and the genotype, then the data were useless to another researcher. But to keep those within the data made the people identifiable. So in a case like that, you can use access control and say, we are going to only allow access to these data under incredibly strict circumstances. So within your research group or your school, you might put an data access committee in place. The CSO also restricts data in using this function. So they make anonymized files available through ISDA, as do Growing Up in Ireland and TILDA, but they also make the full researcher microdata files available, which are not anonymized, which don't have all this aggregated data in them, and they only allow access to those under very strict conditions. So you can balance the anonymization with access control as well. Okay, so thinking about any legal or ethical requirements, if personal data are processed, how will you ensure compliance? And then are there any other legal issues, including intellectual property rights or ownership? So if you feel that you have intellectual property within your data, you can contact UCD Nova and they will help you figure out how and if you can commercialize those data. You would have to apply for a patent on that, and it means you can't publish on it or even talk at a conference about it or put it into a poster or anything like that. So if you feel that your data or your project could be commercialized in some way, you have to be super careful from a legal point of view what you do with it. And again, UCD Nova have access to legal experts who can help you with that. I'm now going to move on to data sharing, long-term preservation, which is an area I'm probably a little bit more comfortable with as a librarian. So how and when will data be shared? Are there any possible restrictions to data sharing or embargo reasons? And again, this is essentially what your funders are asking about. How are you going to make the data available? If you are getting funding from any of the Irish funders, they are all publicly funded. So therefore, the argument is that the public should have access to the outputs, including the data. And also they don't want to fund the same thing multiple times. You might also have a vulnerable population. For example, I was talking to a research group who were dealing with mental health issues among teenagers, and you don't want to keep going back to the same vulnerable population again and again to study them. If the studies have been done once and can be made available, either under very strict access conditions or being anonymized, it means that you're not constantly going back to that same vulnerable population to do the research on them. So the benefits of data sharing for you is that you can ensure reproducibility of your results because you have published the data, you've made them available, anyone can download them and have a look and make sure that what you have said is accurate. Preservation of research data is also really important. So depending on the study that you're doing, there might be a really good reason that you want to preserve them into the long term. Innovation and impact are also very important to the funders, and you may have a greater impact if you're making those data available to someone else. And funders and journals also have requirements around data sharing, and increasingly so as well. So your journal publishers may allow you to upload supplementary information. This isn't ideal. I mean, it's better than nothing, but there's no one really looking at the file formats that's being used or the metadata or how much documentation you're providing with those files. So I would advise you put them into an archive or repository rather than just as supplemental information to your papers. The European Commission coined this phrase, so as open as possible, as closed as necessary. Which I think kind of encapsulates it quite well, and most people have taken this on board. So you want to make your data as open as you possibly can, but understanding that there are restrictions to data sharing, so it's closed as necessary. So this is a photograph that was taken in 1899 of the Muir Glacier in Colorado in the US. So this is obviously a really old photograph. This is the same exact location taken in 2003. So you can imagine, so first of all, this demonstrates the photographs are data. This is completely valid data with the photograph. You can imagine that the original photographer couldn't have imagined what might happen in the intervening 100 years and how his data would be reused in a novel way or for some different piece of research. So just because you can't think of how someone else might want to reuse your data doesn't mean that they won't think of something that they can use your data for. In terms of persistent identifiers, I've talked a little bit about this already. There are different types of persistent identifiers that you can get for your data, but basically if you put them into an archive or repository, most of them will assign a DOI, a digital object identifier, and this is the same system that's put in place for your publications. So it means if the archive moves or loses funding and the data are moved to a different archive, so any archives with the court trust seal that I mentioned earlier will have to have a process in place. So if the funding runs out for example, that they have something that they're going to do with your data, so they know what they're going to do in that case. And that means that once you have the DOI, that will track the data around, so you don't need to worry about it. You'll be able to find the data again, having a DOI. So then when it comes to making the data available, so ideally choose a discipline-specific repository. So again, talk to your colleagues, talk to your supervisor to see if they have ever deposited data anywhere, if they have ever accessed data from your discipline from anywhere. That might be a good starting point. We have re3 data. So re3 data is a registry of data repositories. All of the data repositories within that registry have to be associated with some kind of an academic institution, and there are other restrictions in place so that you have some kind of quality assurance when you're looking there. PLOS and Scientific Data both also have recommended data repositories for specific disciplines. So it's worth having a look at those. Within Ireland, we have the Irish Social Science Data Archive that I manage. So if you have quantitative social science data, you can come and talk to me. If you've got qualitative social science data, there's a qualitative data archive in Maynooth. And then if you have any kind of cultural heritage data or anything like that, you can talk to my colleagues in UCD Library and they will be able to help you or advise you. So if no disciplinary repository exists, And there are lots of reasons why you would choose a disciplinary repository, so your data are more findable because they are located with data of a similar type. The repository will most likely have requirements around file formats and around the metadata that you give them. So within ISDA, we have a file format policy that people can use and say to their funder, well, look, we have looked at best practice within the area and what file formats are going to be accessible into the future and made decisions around that. So that means we've done the work for you to a certain extent. We also have a metadata template that we ask people to fill in before they submit their data to us, which, depending on how much work they've done in advance, may take an hour to maybe 4 hours if they really have to go to a lot of places and pull information together. This is based on the Data Documentation Initiative, so you don't need to know anything about DDI. I know the information about DDI, and I'm giving you a metadata template which will map then to the international standard. So those are the reasons that you might choose a disciplinary repository. If one doesn't exist for your discipline, there are a couple of different multidisciplinary repositories that you can have a look at. Some of them do have a cost associated with them if you go over a certain size. And again, that's something that if you are aware of it at the beginning, you can cost that into your data management plan and into your funding proposal. So again, it's worth thinking about these things just from the very beginning of the research. I don't specifically recommend any one of these over the other because I haven't gone thoroughly in depth into all of the different processes that they have in place. So how and when will your data be shared? And are there any restrictions on data sharing or embargo reasons? So as I said, if you want to make your data fair, this is a step that you're going to have to do. The funders are pushing you in this direction. If you feel you have very sensitive data which can't be shared, that's a really good reason for not sharing them. If you have commercial data within it, if you are using third-party data that might restrict data sharing, as long as you justify it within your data management plan, then the funders will be happy. So either you share it or you give a good reason for why you can't share it. So ideally you would be sharing the anonymized version, so the cleaned version of the data, rather than the raw data, which could potentially contain direct identifiers.
Just puts age or something.
Yeah, and you would probably aggregate that even further. So it might be like someone between 35 and 40 and 39 and 40 and 44. So you'd probably band those ages as well, rather than giving discrete ages. So this is all the data cleaning. So if you have access to someone who can do that for you, that's amazing. Or if you feel that you will need to buy in the time, which comes back to your question from earlier, of someone to do this for you, you can cost that into your funding application from the very beginning, because that will take a lot of time. So to make it really fair, ideally you would make the metadata available somewhere and say these data are available by contacting me directly and under these certain conditions. So you would make the metadata available even if you can't make the data available. Okay, so this last section is pretty quick. It's data management responsibilities and resources. If you are the PI, then you are most likely the person who's going to be responsible for this ultimately. If you're working on a PhD or postdoc, then you are going to be responsible for your own data management. And what resources will you need in order to be able to carry out what you've said you're going to do within the data management plan? So this comes from a slide that Wellcome produced. So giving an example of what they will and won't fund. So in terms of people, they'll fund support for a full or part-time dedicated data manager or data scientist, but not occasional or routine support from institutional support staff. So you can't cost my time, for example, because I'm core funded by the university, into your data management plan. But if you're bringing someone into the team, you can cost that. If you need any software training for any of your participants, you can cost for that as well. In terms of storage or computation, they won't fund costs associated with routine data storage. So like access to Google Drive, for example, which is routine data storage that's made available through the campus. But if you need to buy dedicated hardware to store that somewhere, they'll pay for that, for example. And then in terms of the creation and reuse of data, so they'll pay for costs to access data. So if you are accessing data that you have to pay for, they'll pay for that. for transcription, for anonymization, for obtaining informed consent, because that may take a little bit longer. Transcription obviously is quite a laborious process, so they'll pay for that. Anonymization again is something which is most likely going to take you quite a bit of time and expertise as well. So they'll pay for that. And then if you are preparing your data for deposit with an archive repository, any additional data cleaning that you need to do on it at the end, I mean, you're probably talking about maybe a month of someone's time or a couple of weeks, depending on the complexity of the data. And if there are any ingestion costs, so if any of the repositories have kind of an upfront cost for depositing the data, they'll pay for that as well. But they won't pay for general maintenance beyond the lifetime of the project. All the money has to be spent within the project itself. So that is pretty much all of the sections covered of the data management plan. So I'm going to point you to our library guide, which is libguides.ucd.ie/data. It's divided into those 6 different sections of the data management plan, so it contains a lot more detailed information and pointers to other resources. Our data management checklist is also available on the website, and we've just produced one for student projects. So it's a 1-page, it's much more trimmed down. So if any of you are supervising undergrads or master's students and you want to get them to do it, there's a checklist that they can use. We have a separate LibGuide to do with FAIR data, so if you want to learn a little bit more about that, you can. If you want to get me to review a data management plan, I'm more than happy to do that, either at the funding application stage or post-award. Just send me an email and we can either set up a meeting or we can do it over email, whatever is easiest for you. If you're still sitting there going, I've no idea what she's been talking about for the last hour and a half, give me a shout and I'll sit down and go through everything again with you. That's my job, that's what I'm here for, and I'm more than happy to do it. Thank you very much.